Start tayo. So, example tayo dito. Itong socket wrench. Yan, sukatin natin ang laki niya. Yan. Kung gusto nyo na hindi siya ma-move, so pwede nyo i-lock yan. So dito, ang always nyo talagang hahanapin is saan naka-point yung 0. Huwag yung N. Huwag dito sa N. Yung 0 talaga. Saan siya naka-point. So kung ating bibilangin, so ang 0 is naka-point sa, kasi 20 to, 25, 26, 27. So 27 mm mahigit. So ngayon, hindi natin makukuha yung point niya kung hindi tayo titingin dito sa kanyang Vernier scale. So dito tayo kukuha ng point. Ngayon, sa pagkuha ng kanyang point, hahanapin mo yung, tawag natin dito, hahanapin mo yung number dito sa baba na tugma sa linya dito. So ang titignan mo lang dito sa ibabaw, sa main scale is yung mga line. So wag ka nang tumingin dito sa mga numbers. Yan, sa mga line. So sa nakikita natin, pinaka tapat na linya. Kung ma-observe niyo, hindi nakatapat yung ibang mga linya. Merong malapit at merong sakto talaga. So itong 2. So ibig sabihin, dahil 2 yan, so dahil 0.5 yan kada linya, so 5, 10, 15, 20. So ibig sabihin, 0.20 siya. So 0.20. At i-add mo doon sa 27 na nandito sa kanyang main scale. 27 plus 0.20 is 27.20. Dito naman tayo sa kanyang upper jaws. Yan. So ganito lang. So yan. So ito is babasa naman tayo. So dito ka na naman sa 0. Ayan, 0. So dito is 10, 11, 12. Ayan, so hindi siya umabot ng 13, 'di ba? So 12 lang siya. So 12 yung main scale niya. So 12. So sa point ka na naman kasi hindi lumagpas siya. Dito hanapin mo naman yung katapat na linya. Ayan, makikita natin dito tumapat sa pinakatapat talaga personally is dito sa kanyang dito between sa 9 at saka 8. Yan yung pinakatapat talaga sa personal. 0.80 plus 5 is 0.85. So 0.85 siya. So ibig sabihin 12.85. Yan. Ito naman tayo sa tawag natin hindi aabot ng 1 mm for example. Mga ganyan. So yung 0 hindi umabot ng 1 mm. So pwede rin. Ayan, napakanipis. Di ba? So pwede mo rin yung i-reading dito. Yan. So hanapin mo lang yung linya na magkatapat. Yan. So nandito sa 7. Yung pinakatapat talaga. Yan. So personally is equivalent to 0.7 or 0.70. Dito naman sa likod, ganun pa rin. Sukat natin yung depth gauge, baga yung lalim. Yan. O dito naman, babasahin natin. So 0 agad. Huwag kayong dito sa pinakalas, yung 0 agad. So lagpas siya ng 41. 41 plus to. So point ka na naman. Yan. So hanapin mo na naman yung nagkatapat. So 2. Dito sa 2, yung pinakatapat. Ibig sabihin 41.20. Yan. 41.20 kasi 5, 10, 15, 20. Kasi 0.05 ang bawat linya dito sa baba. Yan. So ganyan lang kadali mga boss. Grading ng Vernier caliper. Thanks for watching mga boss. God bless. Sana may nakuha kayo. See you at the next video.
Hello guys. So this is Russell Journey, your engine cadet. So for today's video, pag-uusapan lang natin kung paano nga ba bumasa ng tinatawag nating micrometer. Ang micrometer guys ay sumusukat sa mga bagay na mas accurate, no? Kumbaga, yung kanyang value na kanyang sukatin is from 0.10 thousandths yung decimal sa mm, no, na kanyang sukatin. Ang unit para natin guys ay mm dito. So ito from here, no, from here to here is 0 to 25 mm. Yan. Ito yung thimble. Ito yung lock. Yan. kung ilalak natin yung sinukat natin, no? Tapos ito yung kanyang sukatin, no? 0 to 25. So dito tayo, right? Mabilis lang 'to. So ito yung mm natin, no? 0 to 5 mm, right? Ito ay 10 mm hanggang 25 mm yan, guys. Kung mapapansin natin, may mga guhit siya, no? So yan ay 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So parang ganyan lang yan. Kung mapapansin natin, guys, meron tayong guhit sa baba. So yan, guys, ay 0.5 yan. So paano? So ito ay from 0 to 0.5, tapos 1, 0.5, 2.5, yun, 2.5, 3, 3.5, 4, 4.5, tapos hanggang maging 5. Ganun yan, no? Yung ilalim yan. Ano naman yung makikita natin number dito, no? Yan. Kung papansin natin, pag tinapat natin dito yan, sa 0, no? Yan. Pag tinapat natin sa 0, yan ay, talaga, 0.5 na, saktong 0.5 na yan. Chabol, 10, 11, 12, no? Ayan o, ayan yung guhit. 10, 11, 12, tas 0. Kung mapapansin natin, nakatapat siya sa 5, which is, siya ay 12.5. Yan. So, doon tayo sa basic muna, no? So, paano naman pag dito nakatapat? Yan. Sample dito, nakatapat sa 10 natin, 10. Yan. 10. Yan. Kung mapapansin nyo, sakto nakatapat sa guhit yan. So, yan ay 10. No? E, paano naman, guys, pag gumanito? Yan. Example. Yan, 10 na yan, di ba? Yan, lumagpas sa 0.5 ng 10. Lang ha, focus lang natin. Yan, lumagpas sa 0.5 ng 10 dito. Yan. Lumagpas sa 0.5 ng 10, no? Tapos meron dito. No? So, paano natin susukatin? So, meron tayong 10.5, hindi naman siya umabot sa 11 eh. So, siya ay 10.5, tapos ipa-plus natin yung nasa timbol. No? Yan. So, yan. Meron tayong 10.5, no? Yan. Meron tayo dito 10.5. Ipa-plus naman natin. Yan. Meron tayong 10.5 dito. Ipa-plus naman natin yung nandito. No? Eto, guys. Yan. Mga decimal yan. Ipa-plus natin yan sa 0.5. Example. Para mag-gets nyo. 0.5 and 0.5 plus point. Decimal to, no? Ilan yan? 20, 21. Kung ano yung nakatapat dito sa gitna na guhit na to. 21, 22, 23. So, let's say hindi na umabot ng 23. Let's say na 22 na lang siya kasi hindi na siya umabot eh. So, plus 22 natin. Sorry, plus 0.22. Yan. So, 10.5 plus 0.22, ang kakalabasan natin ay meron tayong 10.72 mm, no? Yan. So, meron tayong 10.72 mm. So, ganun yung pagsukat ng ating tinatawag na micrometer. Yan. Ipa-plus mo lang to sa point, sa any decimal number ng ano natin, ng nasukat natin. So, ibig sabihin, ganun lang. Ito, ipa-plus mo lang yan. Yun lang. Salamat.
Welcome to the training module on dial indicators. Dial indicators are commonly used to measure runout. There's axial runout and radial runout. Runout is the untrue movement or motion of a rotating object. It is also used to measure axial clearance, which is the axial free movement of an object. This animation shows axial runout on a ring gear. The gear is wobbling, therefore the dial is bouncing back and forth, showing the amount of runout on the ring gear. This example shows how we can measure axial free movement of a gear. The amount of movement the gear moves back and forth between the thrust bushings is measured on the dial indicator. This is an example of a 1-inch linear dial indicator. On the far right, we have the tip that screws to the plunger. Then you have the body of the dial indicator and the dial itself, which has a scale on it and the needle that moves. On the top left is the scale lock. Loosening the scale lock allows you to turn the outer scale for calibration. In addition, we have the range. This number here, it tells us the range of the dial indicator. This one is a 0 to 1 inch range, and the units of measure or accuracy. Here, we are measuring in inches down to 1/1000th of an inch. And finally, the revolution counter. The revolution counter counts how many times the dial has actually gone around. This is a 30,000th of an inch dovetail dial indicator. Here we can see that we have the mounting locations, the body, the plunger, the mounting adapters, and the dial itself, and the units of measure. Reading the 1-inch dial indicator. The large scale number in black are from 0 to 100,000ths of an inch. The large scale numbers in red range from 0 to plus 50,000ths of an inch and from 0 to minus 50,000ths of an inch. The scale in the middle records the number of revolutions. This recorded one full revolution of the big scale for every number on the small scale. The number 1/1000th of an inch in the middle indicates that each large scale line is equal to 1/1000th of an inch. When measuring a value that is greater than one full revolution on the large scale, we need to look at the small scale as well because that counts the number of turns. In this example, you can see that the small scale has actually passed the 4. This indicates the large scale has gone around 4 times and that equals 400,000ths of an inch. Now take a look at the outer scale. The black number reads 20,000ths of an inch. If we add both of these numbers together, we come up with the value of 420,000ths of an inch. Can you tell me what this dial reads? Look closely at the small scale. Notice that it's almost at 400,000ths of an inch, but not quite. Now look at the large scale. Add these two values together. You should come up with 397,000ths of an inch. Now let's look at reading the dovetail. This dovetail reads a maximum of 30,000ths of an inch. Therefore, we use it to measure small measurements. We use it where a linear plunger won't work. Take a close look. Each line measures 5/10,000ths of an inch, or also known as 1/2 of 1/1000th of an inch. Every 2 lines equals 1/1000th of an inch. When I read the dovetail, I typically count by halves. For example, my first measurement is going to be 1/2 of 1/1000th of an inch. Then the next line is going to be 1/1000th of an inch. Then 1.5 thousandths of an inch. Then 2 thousandths of an inch. 2.5 thousandths. And finally 3 thousandths of an inch where my pointer is lined up to. Take a look at this reading. Here it is showing 12.5 thousandths of an inch, or it could be stated as 125/10,000ths of an inch. It would be written as 0.0125 and the close quote mark using the close quote symbol indicates inches. Dial indicators rarely measure static value. Often the movement is less than 100,000ths of an inch. Therefore, we don't need to look at the small gauge because it is less than one full revolution, and we measure total needle movement. That means we add the negative movement to the positive movement to get the total movement. Notice the needle moves from plus 5/1000ths of an inch to minus 90,000ths of an inch. The total needle movement is 15,000ths of an inch. The needle moves 10,000ths of an inch to the negative side, then 5,000ths of an inch to the positive side, for a total of 15,000ths of an inch. Here on the dovetail, we're watching the movement of the needle. The movement is from 4.5 thousandths of an inch on the minus side to 5.5 thousandths of an inch on the minus side, for a total movement of 1/1000th of an inch. What is the total amount of movement on this dial as it swings back and forth? If you figured it was 42 thousandths of an inch, you are correct. How much total movement is shown here on the dovetail? Did you figure 6.5 thousandths of an inch? If so, you are correct.